ஸ்டார்ட் பண்ணவே இல்லை. ஜாயின் பண்ணிட்டாரு.
Hello, is it audible for you? Hello all, good morning. Is it audible?
Good morning, sir.
Good morning, sir. Yes, sir.
Okay. So I am teaching you from Kerala, so mostly I will be using English. Is that okay for you?
Yes, sir. Okay, sir.
I know a little bit Tamil, but if I teach in Tamil, it will be a disaster. So let's see how the class is going today, and we will decide how to change or something like that. Okay. So try to grasp in English. So either you unmute your microphone and clear the doubts, or you can just chat also. I will be seeing your chat. So if there is any doubt, please ask me. Don't hesitate to ask. I think we can start. Okay. Are you seeing a full screen?
Yes, sir.
Okay. So we'll be discussing power system. And you know, in most of the, and I wanted to tell you one more thing. Yesterday, RRB, Railway Recruitment Board, published one more notice that they are conducting SSC exam again. Not staff selection, senior section engineer. Till now, they were conducting SSC previously. Before 2 years, they have stopped it, and they were taking only from the diploma holders and degree holders, and the post was JEE. junior engineer. So you have a golden chance now to apply for SSC, that is senior section engineer. So it's a golden opportunity for you, especially you guys. When we apply from Kerala, we will be getting some other states. So you have a chance to get into ICF, Integral Coach Factory. My friends are working there. So don't waste this opportunity. So one time your preparation is more than enough. So if you are preparing for, I will be covering all those questions also. So at a particular point, if you are not understand, if you are not able to grasp any idea or any topic, please let me know. Please ask in the chat or please unmute your microphone and please ask me. Okay, so I'm not telling so many stories because already some of the faculties might have told you. These are the opportunities waiting for you. And yeah, those opportunities are waiting for you. So I just yesterday I came to know that I have received a notice from my friend in ICF, Integral Coach Factory Chennai, and he has given me this one, this letter. So they will be this from this year onwards. They will be asking for. So you have two opportunities: junior engineer and senior section engineer. So the starting salary package would be around 60K per month, right? And JE around 40. So please don't waste. Suppose if you ask TNEB or this one, you go for which one is giving more money, then you should go for that. So both are electrical category only. Now, power system. These are the topics we are going to discuss. So first one is generation, transmission, and distribution. Right. Second one is voltage control and power factor correction. Actually, voltage control is coming under this transmission and distribution. Transmission mainly. Voltage control and power factor correction. Power factor correction. Third one is per unit analysis. Right. Per unit analysis. And symmetrical components. Symmetrical components. Fourth one is fault analysis. Fault analysis. Fifth one is stability. Protection. Economic load dispatch. Underground cables and overhead insulators. Underground cables and overhead insulators. Ninth one, so load flow studies. So these are the main topics we are going to discuss. HPDC and all, they are not asking nowadays. Fax controllers we will discuss after this, voltage control and power factor correction, because this is the baby boy for fax controllers. So after this, we will learn flexible AC transmission system, that is fax controllers. Just note it down. I will share this PPT also to you. Don't worry. So shall we start with generation?
Yes, sir.
Okay. So don't hesitate to ask any doubt. So it's your choice. It's your exam. Even if it is a simple doubt, don't hesitate to ask. Just shoot directly. So I am seeing your chat box also, or you can unmute your microphone and please ask. First of all, what is a power system? You know that system is a thing to do some work. You can take any system. What is bus system? Bus means you're for traveling, right? So bus is a system which you are using to travel. Uh, at the time of asking your doubt, you can unmute your microphone. Now you mute. Okay. Power system. A system is to do some work. So what is power system? Okay. Is for what it is used for. So it is dealing with. So those who are not yet muted, please mute now your microphone. A system which deals with the principle of power generation, transmission. See, we are the customer, right? So we are standing here. So power is coming towards you. Power is coming towards you. So the power is somewhere it is generated and it is transmitted and it is distributed. So the whole system is called as your power system. So the system which deals with the power generation, transmission and distribution. For what purpose? In order to distribute power to consumer. We are the consumer in an economical basis. So it deals with the power generation, transmission and distribution. These kind of things they will not ask in exam. Just realize power generation, transmission and distribution. In order to supply, for what purpose? In order to supply electrical energy to various consumers. So suppose somebody will ask you, especially you don't have interview, I guess, but in the future you will have an interview. They will ask what is the cost of power for 1 unit. So I don't know what is the cost of power in Tamil Nadu for 1 unit. Suppose if they are asking 10 rupees per unit, we will not be happy because in Kerala itself 3 to 4 rupees per unit maximum. So this is not economical basis. Economical basis means the minimum cost. That is the main objective of power system. So nowadays, the central government is planning to put a bill in the parliament so that now there will be a central pool. From here, you can tap electrical energy. It's like Vodafone, Idea, or BSNL. You can choose your network. Similarly, you can choose from where. For local consumers, it would be difficult, but for example, Express Avenue Mall or in Coimbatore, different malls are there. They are using more electrical energy, so their per month utilization would be high. So per month, the cost would be high. So to reduce the cost, they can decide from this is a pool, electrical energy pool. So from here, they can tap electrical power. So they can decide. So now the state government, they don't have any control over it because the state government cannot tell you that you should take BSNL, you should take Vodafone, you should take what do you say, Airtel like that. You can choose. You are the boss. So from where you are getting cheap energy, you can select it. So now it is going to happen. So which means simply the distribution side it is going to be privatized. The central government is planning like that. So from if you are the customer, you will be happy. So power system, it is having an objective. It deals with the power generation, transmission and distribution. For what purpose? In order to supply electrical energy to various consumers in an economical basis. In an economical basis. Are you understanding what I'm saying?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, okay. So this is power system, and believe me, they won't ask it in exam and all. What is power system and all? No, you just need to realize what is a power system. So it's not only transmission. The power system means the first thing it is coming to you, that is distribution, the lines, right? It's not only like that. It also includes generation, transmission, and distribution. You should know how we are controlling the voltage and current. Okay. So now you know that how the billing is coming and all, kilowatt hour, right? Because electrical energy you are utilizing. So which means it is power into time, right? Power into time. So how much electrical energy you are utilizing based on that. Power means watt, kilowatt, megawatt. For you it would be kilowatt, more than enough. Time means the unit is hour. So based on this you will be getting billed. So 1 kilowatt hour, you should realize that it is 1 unit of energy. 1 kilowatt hour is 1 unit of energy. Okay. So we'll be learning that in economic load dispatch and all, right? So what, and after distributing the power, this electrical energy, it would be used for mainly two purpose. First one is called as illumination purpose. Illumination means artificial lightning, right? Or bulb, light bulb. That would be 10% of the electrical energy is needed. The remaining it is to drive mechanical loads, which means if the light is 15 watt maximum 15 watt is enough. But our fan, the ceiling fan is 60 watts. Nowadays, BLDC fans are available. Brushless DC motor fans are available with 20-25 watts. BLDC fans. 60 watt is our normal ceiling fan rating. So you should know, if you are using a motor, normally in Chennai and all, you will not be using motor. For the whole flat, you will be using one motor to pump the water, and that would be around 3 HP. 3 HP means 1 HP, you should realize 1 HP is equal to 746 watt. So what is 3 HP? 3 HP means 3 into 3 746 watt. See, when you compare this light, the unit of light, the power is 615 watt only. But if you see your motor in your home, it would be more than 1000 watt. So the remaining 90% of electrical energy is to drive mechanical loads. Right. So that would be around, sorry, 90%. So because these guys, they require more power, because our ceiling fans, fridge, AC, washing machine, they are not light loads, they are heavy loads. So they require most of the electrical energy. And how this electrical energy is generated? The electrical energy which we are seeing now, electrical energy, it is generated from mechanical energy. So mechanical engineers existed first, then only electrical engineers existed. And this electrical energy is further is used to drive mechanical energy. You can see a simple example, that is electric traction. Electric traction, our suburban trains. In Chennai, you will see so many suburban trains, and also you have seen so many trains which uses electrical energy. So actually, first of all, how this mechanical energy is created? So there are two. Mechanical energy is already available in the nature. So how this conversion, mechanical energy to electrical energy, is done? That is our first chapter, that is generation. Two types of mechanical energies are available. You can classify it as conventional and non-conventional. Right, non-conventional. So these two types of sources, which we are using these two types of sources, and we are converting that energy to electrical energy. And what is the need of this conversion? See, mechanical energy, we cannot store it. We can store it, but it is very difficult. Mechanical energy is, this is an interview question. How we store mechanical energy? How we store mechanical energy? It is a very simple example is you are cycling. Cycling means how to right cycling. So you are pedaling, right? When you are pedaling, the mechanical energy is stored in the flywheel. So what is flywheel? What is the cycle rim? There also rim in you are telling rim, no? Cycle rim. Yes or no? You have a tire and you have a ring.
Yes, sir. Yes,
Rim.
sir.
Rim. So that mechanical energy is stored in the rim. That rim is also called as flywheel. So we can store mechanical energy. That is also by using flywheel, but it is this flywheel is storing very less mechanical energy. But how you can store electrical energy? It's very easy, battery. That's why nowadays battery powered cars are coming. So why we can use direct mechanical energy? Because suppose for hydroelectric or steam turbine, that turbine can be coupled to direct mechanical drives, right? Mechanical drives like the suburban trains, but it is actually impossible. Possible, but actually impossible. Which means you are coupling the turbine with mechanical load. Suppose this is a motor, mechanical motor, right? It's a motor. Suppose if you are using steam, right? And if you are able to run this turbine, the turbine is running at 1000 rpm, 1000 rpm, and the motor maximum rpm is 500 rpm. How will you couple directly? Can anyone answer this? One is running with 1000 rpm and another is running with 500 rpm. But if you directly coupling this, what will happen? The motor will damage because the maximum rpm is 500 rpm for motor. Can you tell me how you are able to? This will be possible, but you tell me how is it
Here,
possible?
sir.
Yes, very good. Now in between you are applying some gear, and this gear will control the speed. This gear will convert this to 500 rpm gear. Now you can run your motor. But the problem is that you are wasting some amount of energy in this gear, right? Because energy cannot be destroyed, cannot be created. One form of energy can be transferred to another form. That's all. That is conservation principle, because some amount of energy is wasted here. So what I'm saying is that if you are using directly mechanical energy and you are driving some mechanical loads, the problem is that you will have power wastage. Power will be wasted. And why we are converting to electrical energy? Because the power wastage can be minimized. So first you convert mechanical energy to electrical energy, then you convert electrical energy to mechanical energy, that is motor. So this operation is generating action, generator, and this operation is motor. So the power wastage can be minimized. So that's why we have generated electricity. Minimized. So my question is that You have two kind of electricity. One is DC and another one is AC. Who invented DC and who invented AC? Alternating current.
Edison and Tesla.
Which one?
Edison and Tesla.
Tesla found AC or DC?
AC.
AC. Very good. Tesla. And DC? Don't worry,
Edison.
don't. Not an Edison. Already DC existed. Edison worked on it. That's all. Before Edison, Benjamin Franklin was here. Benjamin Franklin also was experimenting in DC only. So who found DC actually in the sense 6000 or 8000 BC, the first when Greeks, there was a glass and amber. This is glass and amber, the material was there. When they rubbed amber with glass, electricity generated. So that was the first concept, and the first electricity was DC only. Edison did not invent DC, and you know that there was a war between Tesla and Edison. So I'm not writing Edison here because he did not invent DC. For me, the best scientist is Tesla only because he invented AC, and we know that the 99% of world electricity is again AC because of the beautiful invention of a beautiful device in our power system that is called as transformer. Because AC could be uh, transmitted for a long distance. That is the power of a transformer. And who invented transformer? Who invented transformer? We are electrical engineers, right? So we should know who invented transformer. Tesla did not invent transformer, okay, first of all. Transformer invented by ZBD. ZBD means it's called as, you can Google it, Zipernowski Blatty Dairy. So these three people invented transformer, the which one we are seeing now. So, and Tesla utilized this. So he's a genius, you know. If suppose Tesla was a businessman, he would be the most the Amazon, you know, Jeff Bezos, he's not now the richest man. Yesterday or day before yesterday changed, I guess. And if Tesla was alive today and he was a businessman, he would be the richest person in the world but he was a good human. That's why there was a big story behind this Tesla versus Edison. So many articles are there, so many movies are there. You go and watch. I'm not wasting my time for that. So suppose if we leave that behind, we are preparing for TNEB. So there are two types of power generation is possible. So we have seen the two sources are available. One is non-conventional energy resources, non-conventional and conventional. They may ask which of the given energy resources are non-conventional or no conventional. So non-conventional energy resources, they are called as renewable, and these are called as non-renewable. What is the meaning? Renew, renew, which means
Reusable.
reusable. See,
Reusable.
reusable. See, even if you tell in Tamil, I can understand because I can understand whatever you are saying, but the speaking there is a difficulty. And I was teaching in SRM University for 2 years. There itself, I have struggled for 2 years in Chennai. You know, na? SRM University. Anyone from SRM University? No. Okay. So this is renewable and this is non-renewable. Tell some example, please let me know some example. Here the capacity, how much capacity you can generate, it is small capacity power generation. Small capacity power generation. Here bulk amount of power is produced. Right. You tell some example.
Solar,
Solar,
wind,
wind,
Yes. Solar, wind.
hydro,
Hydro, you are producing only small capacity of power generation. We are from Kerala, okay. I am from Kerala and we are using hydel. Bulk amount of power is produced. Huh. 1 second. Okay. So, okay, where were we? So solar, wind.
geothermal,
Tidal, geothermal. What is geothermal?
from the earth we are getting.
From the earth. So I will explain that. Then we don't have much time, right? For because it is TNEB examination, and you don't have. I think you don't have interview also. Do you have interview or just you have a rank list?
No interview, sir. Only exam.
Very good. Escaped. Actually, that is good only. This culprit politician, they will ask money from you. So it is better. Solar, wind, tidal, geothermal. It's also called as biomass. And you search in the internet and you tell me what are those. And it sometimes you will have this also. What is this MHD? Anyone can tell me, and can anyone tell me this MHD? You search and you will see some animation also in YouTube. It's called as magneto hydro power generation. This one you search, okay. It's better you see some animations. You tell me some bulk amount of power generation. So from here you may get one question that from the given 4 options would be there. Which one is renewable? Which one is non-renewable? It would be very easy for you. It is asked in some JE level question. So you are preparing. You are not only preparing for TNAB. Whatever exam is coming to you, you go and write. Okay. Bulk amount. Tell me what are those?
Thermal,
Thermal,
nuclear,
nuclear,
hydel, gas, diesel.
diesel,
Yes. How many nuclear power plants are there in Tamil Nadu?
2, sir.
Which are they?
Kudangulam and Kalpakkam.
Very nice. So you see from in Tamil Nadu, I think thermal power generation is very high, right? Nuclear 2 are there, but thermal is very high because Ennur region you will get so many nuclear thermal power plants. In India, overall, if you see, how much is the power generation? It is around 3 lakh megawatt. 3 lakh megawatt. 3 lakh means 3 lakh megawatt. So now it's more than 3 lakh megawatt for now. Maybe it might be 4 lakh megawatt. It is based on the previous data. 3 lakh megawatt means you compare with your one light bulb, that is 15 watt. 1 megawatt equal to how much watt? 10 raised to 6 watt. Now it is for overall India, but still, you know that in some village areas, there will be some 5 hours, 6 hours power cut, which means still India is a energy deficient country. And please tell me, out of which power plant produces highest amount of power in India? You don't consider renewable because it is a small capacity power generation. So this is the bulk amount of power generation in India. Out of which you tell me which answer is thermal power plant.
Thermal.
Yeah, you
Steam.
have thermal. Yeah, thermal. So 60% of the power is coming from thermal in India. 30% is coming from, after thermal, can you tell me which one?
Nuclear.
Tidal. Because you might not see in Tamil Nadu so many power plants, but Kerala is there. Haryana, it's not Kerala, Haryana, Himachal Pradesh, and northern states, they are producing much amount of power from hydel. So around 30% is still coming from hydel. So remaining 10% is coming from solar, wind, and all. So now it may change because after so many years, hydel and thermal power plants, they are going to be decommissioned. So nuclear power plants, you know, they will also get decommissioned. And then renewable energy, it would, you know, Adani Power. He is producing much amount of power. This may vary. Okay, this is not fixed. This is based on the previous data, and wind. He is producing much amount of power from wind. So now he is and Reliance Power, Adani and Ambani, they are going to be in. I think the privatization is actually it will be helpful for them, and it will be helpful for the for you also. I told you what is pool, electrical energy pool. Suppose if you are getting 2 rupees per unit, you should take that 2 Rs per unit. You should take that. If you are running a big industry, you should take that, because if you are currently, if your uh, bill, annual bill is not annual bill, monthly bill is 2 lakhs per annum, 2 lakhs for electrical energy, it would be reduced to 1 lakh. So you would be happy, right? So here, if you consider, see how many are there: solar, wind, tidal, geothermal, biomass, MHD. Here, one person is exceptional. Except that person, all the energy conversion is in rotational manner. Then you tell me who's that person. Either you use non-conventional or conventional, some energy is converted to electrical energy. And here you have discussed so many things, right? So one type of energy conversion is not in rotational manner. What do you mean by rotational manner? Rotational manner. Because here the turbine is rotating, turbine is rotating, turbine is rotating. Yes, turbine is rotating. Diesel is rotating, MHD rotating,
Solar, sir.
biomass rotating. Solar. Have you ever seen a solar cell rotating? No. Because the operating principle is different. So except solar energy, all other energy conversion is in rotational manner. Except solar energy. Right. Now, again, we will classify non-conventional, conventional. You tell me, in non-conventional, except solar energy, all other types of energy conversion is in rotational manner. So in non-conventional energy resource, which type of generator you are using? We are generating AC power only. So you tell me, two types of generators are there. So you tell me which generator is using where, which generator is using where. Here. In non-conventional, like in tidal wind. Even if it is wrong, no issues. Don't worry at all.
Non-salient
Which
pole,
generator?
sir.
Which one?
Non-salient pole generator.
Non-salient pole means, yeah, you are telling about non-salient pole. What type of generator is that? No, you're telling, yeah, something you are getting. Non-salient pole means?
Synchronous generator.
Sorry? Yeah, synchronous, right?
Synchronous generator.
Synchronous generator. So you have two types of generator. One is synchronous generator and one is asynchronous generator. What is synchronous generator? You tell me whatever is there in your mind, you tell me. If it is wrong, we will change it. Tamil pesunga, I can understand.
Rotate in a synchronous speed, sir.
Rotate in a synchronous speed. So which means, so you have
Doubly
to
excited
study like,
emission.
no need and all. Just you tell me synchronous generator, it is rotating in. So synchronous generator is there. You listen carefully. This is synchronous generator. Synchronous generator, the speed must be ns, synchronous speed. Okay. So to rotate this generator, I need a turbine. So I need a turbine. You tell me, this synchronous generator will rotate only in synchronous speed. And this turbine should rotate only in synchronous speed, which means the input mechanical power PM, or you can say mechanical power, or it's called as shaft power PS. This should be controlled, right? Which means you tell me where the power can be controlled. Here, the input energy is wind, tidal, etc. Wind, tidal. Can you control the wind power? Unless you are a god, you cannot wind power, right? Here steam input, the water input, hydroelectric. This one you can control it or not?
Control, sir.
You think you are controlling a tap. This is a tap, okay? And this is the flow of water. You can, by controlling the tap, you can control the flow of water. Similarly, you can control the steam and water to this turbine, so that it will always run at synchronous speed, and the synchronous generator is also running at synchronous speed. No issues. Everyone is happy. But can you control the wind power? Can you control the tidal power?
No, sir.
No.
No, sir.
Then you tell me, then the turbine will rotate freely. It will be other than synchronous speed. So you tell me which generator I have to use it here.
Asynchronous generator used in non-conventional.
That's all. That's all. Asynchronous. You tell me one example for asynchronous generator.
Induction generator, sir.
Very good. Induction generator. Someone told no, non-salient pole. Non-salient pole is actually synchronous generators are again classified into two. One is salient pole, another one is non-salient pole. Non-salient pole
Non-salient.
means it's called as other name.
Wounded rotor.
Not wounded. Wounded is in induction. It's cylindrical.
Okay, okay.
Cylindrical, or sometimes called as round rotor. That also, that and all you will learn in machines. Okay, so this whole story is about, if you learn like this, you will not forget. So in conventional power plants, you are using synchronous generator. That's all. And you know that Suppose if this is my generator, you listen carefully. Generator, you have a shaft power, and the shaft power, that is mechanical power, which is converted to electrical power. Shaft power or mechanical power is converted to electrical power everywhere, here also. Here, because I am using this convention everywhere, this is your shaft power and this is your electrical power. You tell me, what is the difference between shaft power and electrical power? Equal to 0 or not equal to 0? Here, shaft power minus electrical power. Where it will be equal to 0? You don't consider the losses. You don't consider the loss. Sorry.
Conventional side is equal to
Balance
zero.
system.
Ah,
In balance
yes.
system,
Yeah,
P is equal to P.
Yeah,
rotate in a
because
synchronous speed, that's also equal.
very good, very good. Because the shaft power will be constant. You can control the flow of steam, flow of water. That amount of shaft power would be converted to electrical power. But here, what is the problem? No, the shaft power will be changing always, because in the morning, in the evening, the flow of wind, the wind speed is very high. So the shaft power is changing. We can't control it. So this power difference will not be equal to 0. But in synchronous generator, the power difference will be equal to 0. So there is a power, the difference of which is called as accelerating or decelerating power. I will simply say PA. And please note it down. We will be using in stability chapter this power convention. The accelerating, this PA is not only accelerating, it is also called as decelerating power. So PA is the net, it's the difference of your shaft input and the electrical power output. Here also PA is called as, you note it down, PA is called as accelerating or decelerating power. Accelerating or decelerating. Okay. So which means here, what is the accelerating or decelerating power always? In conventional, by using conventional resources, you are using synchronous generator, always you can control this shaft input. PS minus P is always equal to 0, which means neither acceleration nor deceleration. Neither acceleration nor deceleration. Here you can have acceleration or deceleration based upon the wind speed. These and all, it's not important, you just note it down. Okay. Again, you know that small amount of power generation is possible in non-convention. So the capacity of this power generation is around, can you get some of you are working in solar. What would be the maximum power in a typical, suppose if you are buying a solar panel for your home, what is the maximum power you can generate approximately?
1 kilowatt, sir.
1 kilowatt is it's a starting. It may go up to 12 kilowatt. See, it is kilowatt only. So which means capacity of power generation is kilowatt to few megawatt to, so approximately less than or equal to 5 megawatt. Why I am going up to 5 megawatt? Because in India, there is an airport in India which is fully covered by solar. Can you tell me that? Which one? Cochin International Airport. That is in Kerala. So you note it down. Cochin International Airport. Cochin. So there, I don't know what is the power generation, but it would be less than or equal to 5 megawatt only. And what will be the voltage level, power generation? Voltage level. from 230 volt, and it would be 415 volt or 650 volt up to 1100 volt. So it will be low voltage power generation, low voltage. Now you compare with the thermal or nuclear power generation. It would be few megawatt to 1000 megawatt. So it's not only 1000. Now the BHEL is building 1500 megawatt generator. 1500 megawatt means it is a huge generator. Thermal power generation. So what is the voltage level? Voltage level will be the generation voltage. I am telling, okay, no transmission voltage. Still we are in generation level. You can tell some 3.3 kV, then 6.6 kV and 13.2 kV. So again, up to 22 kV. This is the highest in India. Now they are looking for 33 kV. Again BHEL. So 1500 megawatt means the voltage level will be some 33 kV. Now 33 kV is available in France. This is the highest in India, 22 kV. Okay. So now you are producing. See, my next question is, this is an interview question. You are producing sinusoidal waveform. Why sinusoidal? Why sinusoidal? This will not be asked in TNAB, but I am asking you this question. Why sinusoidal waveform? You are producing
Alternative,
only
Alternative, sir. Alternative.
Yeah. Why alternative?
It's a rotating signal, sir. Positive half cycle, negative half cycle. It's a rotator machine.
Then why not this?
Harmonic.
Harmonic, sir.
Okay. This is also sinusoidal, right? I am asking why sinusoidal? Why not triangular? Why not this one? Rectangular and all. Anyone?
So getting more output voltage.
It's not same. You try, no problem. Somebody is thinking about it, but they are not delivering it. See, if your answer is wrong, what is in it? Am I going to publish in the internet? No. I can correct it. You deliver it. The answer.
Calculation purpose.
Calculation purpose, such as
2 pi.
Such as
2 pi.
2 pi. The period is 2 pi. Here also the period you take it as 2 pi. No, one of you told calculation purpose.
Frequency, magnitude, angle calculations must be easy in sine waveform.
No. The 50% is correct for calculation. What are the calculations you are using in mathematics?
We can differentiate and integrate.
Very nice. Very nice. Sinusoidal, sine omega t. Right. If I'm teaching in GATE, no one will answer this question. At least some of you are delivering it, right? Some of you are at least trying. If you differentiate whatever operation you are giving, what is integral sine omega t with respect to d omega t? Minus cos omega
Minus
t.
cos omega t.
What is d by d omega t of sine omega t? Cos omega t, right? And suppose if you are adding with a constant, again you are getting sinusoidal signal. Yes or no? So whatever operation you are doing here, you just integrate, differentiate, subtract, add, multiply with another signal. You definitely, sorry, definitely you are getting another sinusoidal signal. But this is triangular signal. Suppose if we integrate triangular signal, what you will get? In control system, you have learned this is a RAM signal, right? If you integrate RAM, what you will get?
Parabolic.
Step signal, sir.
Parabolic.
Parabolic.
Yeah, it's parabolic. Suppose if you differentiate, what you will get? Step.
Step signal.
So which means the once I generate this signal is going through so many signal conditioners, electronic circuits. So after passing out from electronic circuit, we will know what type of signal I am getting. Suppose if I generate sinusoidal signal, what is the signal I am getting again? Sinusoidal, right? Suppose if we integrate, differentiate, add, subtract, all the mathematical manipulation you give or calculations you give, the final signal I am getting is sinusoidal only. Cosinusoidal means it's again an alternating current, right? Sinusoidal, shifted sinusoidal. Correct or not?
Yes, sir.
Cos omega t means again it's the shape is same. It's just a shifted signal. So from the consumer side, suppose if you are designing an electrical quantity, for example, our ceiling fan, you need the input. Suppose if the input is known, it's very easy for you. If it is sinusoidal, it is very easy for me to design all the parameters here. Suppose if this is transferring through so many electronic devices, right? You don't know what is there in electronic devices, but can you tell me what is the output? Suppose if this is transferring through some electronic circuits like an integrator, subtractor, but you don't know. Can you tell me what is the output? If somebody is asking you, this is the answer. Why sinusoidal signal you are generating in generating station? Suppose if you are passing this triangular signal through so many electronic circuits, signal conditioners, you don't know what is the output. If you don't know what is the output, you don't know how to design a system. That is the problem. You understand why I am generating sinusoidal signal in generators?
Yes, sir.
Okay. So this is the reason why I am only producing sinusoidal signals in generating stations. Right. Next. Based on loads. So power plants can be classified based on load. There are two types of loads. One is called as base load and someone is called as peak load power plants. Base load means, what is the peak load period? This is peak load. Now tell me what is the load, base load or peak load?
The base load is the average consumption.
No. I am telling you this is the, and now this is 10:30 a.m. Now you tell me which period, base load or peak load?
Peak load is morning 6 to 9 or evening 6 to 9.
Very nice. Very nice.
Base load is the intermediate period.
6 p.m. to 11 p.m. that is peak load, because you will be using your TV and AC,
All
every
illuminations.
load you are putting, right? And morning 6 a.m. to 9 a.m. as he said, 9 a.m. or 10 a.m. this is peak load. Now this time, the morning 9 a.m. to evening 6 p.m. that is base load. Base load means that much load you are not utilizing. In your home, everybody is going to office. Now during Corona season, everything is peak load. Base load means base load power plants are now in operation. See, we told gas and diesel, right? Gas and diesel means now you know what is a diesel price. So are you putting now it is 10:30 a.m. Are you using diesel power plant now? What are the base load power plants? This question they will ask. What are the base load
Steam
power
power
plants?
plants.
Yes, base
Steam.
load means steam. Then thermal. These are base load. Now they are working. Hydel,
Sir,
solar.
idle peak load la?
They are working. Hydel. Now we are enjoying. I am taking you class by using hydel energy. Hydel, no, it's no, it's always available. Cheap electricity, right?
Okay, sir.
Nuclear. It is working now. These are all bulk amount of power generation in India. So nuclear. Wind. Now it is working. Whenever wind is available, wind is working now. These are all called as base load power plants. What are peak load power plants? Which means these power plants, base load means always base load is available. You told that what is peak load? Peak load means this much of energy demand should be met, which means I need to operate some more power plants to meet that demand. Such as gas and diesel. Right or wrong?
Yes, sir.
See, suppose if I am putting gas, the gas cost is very high. So it is uneconomical. You should know that power system, it should be dealing with generation, transmission and distribution to distribute electrical energies to various consumers in an economical basis. Economical basis means base load, if you are having 2 rupees per unit, peak load also you should get 2 rupees per unit. So, but the government is forced to operate this gas power plant because the base load, steam, thermal, hydel, solar, nuclear, wind, everyone is operating now. But for example, if everyone is in action, this is the load demand. This is the load which we are giving by this base load power plants. Again, this much of load should be met. Who will give this power? We can't purchase from America, we can't purchase from Australia and all. We should generate ourselves. For that, we require gas and diesel. So they will ask one question in generation, which of these following plants are peak load power plants or base load power plants? So definitely steam, thermal, hydel, solar, these are called as base load power plants. It doesn't mean that they will not work in peak load, they will work, no issues. But there are certain power plants which are specially designed to work in peak load because gas and they are called as gas and diesel. Why not they are not base load? That is very, very easy to explain because the cost is more for gas and diesel. And this
Per unit
diesel
cost is
power
adhigam.
plant, unit cost is adhigama irukkum. And that is not our concern. Government should meet the demand. Right. Suppose if they are not switching on gas and diesel, what will happen? I am not telling about Tamil Nadu, I am telling about all over India. And I am talking about TNEB exam. Suppose if they are asking, even if gas and diesel is not available in Tamil Nadu, you should answer the question. Which of the given power plant is peak load power plants? Diesel power plants are sometimes called as standby. Standby. Why this standby is called as? Have you seen diesel power plant? Have you seen a diesel generator? Because nearby hospital in the basement, you will see a diesel, the green one, a diesel generator. Have you seen that? The big one,
Yes, sir.
hospital or in any shopping complex. This is a green color, and that is, they are using diesel, and you will not hear any sound because of the silencer and all. And that is called a standby. Standby means if the power is failed, they are using diesel generator as standby. That's all. So you must realize what are base load. At least it is very easy to realize peak load. Only two are there, gas and diesel. And for another name for diesel power plant is called as standby. Okay. So based on loads, I'm not telling about conventional and non-conventional. Based on loads, power plants are classified. So steam, thermal, hydel, solar, nuclear, wind, they are called as base load. And this is called as gas power plant. Especially gas and So we can say that all the power plants can be used for to meet this peak load. Don't think like that. In the peak load, that is in 6 p.m. to 11 p.m., only gas and diesel is working. It's not like that. In the peak load, everyone is working, but something is remaining. To this much of peak is remaining. So who will come and meet that demand? This much of load is giving by gas and diesel. You understand? Peak load le steam, thermal, hydro எல்லாம் work ஆகுது. ஆனா இது பத்தாது. This much of load is remaining. Peak load le. அது யாரு வந்து compensate பண்ணுவாரு?
Gas and diesel.
Gas and
Gas and
diesel.
Gas and diesel வந்து compensate பண்ணுவாரு. ஆனா எதுக்கு gas and diesel இங்க வர மாட்டாங்க? Because
More cost,
operating
sir,
cost,
economical.
more,
Economical.
yeah, more cost is there. That's why this gas and diesel is not coming here.
Yes, sir.
Okay, so you realize what are the peak load power plants? Gas and diesel. The diesel க்கு வேற ஒரு பேர் இருக்கு, standby. That's all. So based on location of plants, location, you have two power plants. One is called as non-remote and second one is called as remote power plants. Non-remote and remote power plants, what are they? See, this is my load, which means load means factories or house. These are called as load. You are a load, house, factories, any types of thing, a thing which consume electrical energy, that is called as a load. The power plant, sometimes it is sitting nearer to load. For example, solar power plant, the load is nearer to solar power plant. That are called as non-remote power plants. Solar. What in some sense, what is called as remote power plants? Have you ever seen
Thermal.
a thermal, nuclear, yeah,
Nuclear.
hydro? These are called as remote power plants. Instead of explaining, you know what is the reason. Because hydel power plants, a dam cannot be built near to your house. Where the water or construction site is available, especially in the forest areas, you are building a dam there. That's why the name remote. Nuclear power plants. Suppose if a nuclear power plant, you know that Chernobyl, every electrical engineer should see this, watch this series, Chernobyl. Have you seen this? Chernobyl series. Every computer science engineer should see a movie which is based on Alan Turing. You know what is that movie? Imitation Game. Have you seen this movie? Have you seen the series Chernobyl? This is a yeah, it's a series based on the nuclear disaster in Chernobyl 1986. So I will not teach you this one, nuclear power generation. I will just give a vague idea about nuclear power generation. The 5 episodes are there in Chernobyl series. You go and watch that Chernobyl series, more than enough. So solar is called as a non-remote power plant. Example here, the thermal, nuclear, hydel, they are all called as remote power plants. Right? Now we will learn one by one. We will be discussing thermal and nuclear, and thermal, nuclear and hydel. And I will not be explaining the whole power plant theories and all. Just I am giving a small idea. Thermal power plants. What is happening in thermal power plants? Some of you are working in thermal power plant, worked in thermal power plant, I guess, as apprentice. High pressure and high temperature, steam, high pressure and high temperature steam is converted to electrical energy. So high pressure means it is about 100 to 160 kilogram per meter square, and high temperature means 540 degrees Celsius. You know 540 degrees Celsius. You know what is the temperature for what is the boiling point of water? That is 100 degrees Celsius, you can say. And see, 540 degrees Celsius means it is too much heat. So this, which means is that steam is converted. Steam is used to rotate the turbine, and turbine is here. This is water, and you are using coal, right? Have you seen how coal transportation? These are called as coal. So the water is boiled at 540 degrees Celsius, and this is steam. What is this? One of the main component in thermal power plant. What is this? This is called as boiler. And this steam, there is a turbine. I'm not going to draw the complete diagram. This is a turbine, right? So this steam is going inside the turbine. Turbine is rotating, and the steam is coming out, and it is again condensed, and it is fed back to the boiler again. Again, it is heated, steam is generated, the turbine is, and finally the turbine is coupled with the generator. And the generator finally it is connected to the bus. That is the grid. So this is actually happening in thermal power plant. High pressure, high temperature steam is converted to electrical energy, which means the turbine is rotating, the generator is rotating, electrical energy is generated, and it is given back to the power grid. So the steam coming out from the turbine, it is cooling. It's cooled down, and it is fed back to the boiler again, because this is not a simple water. It is called as demineralized water. This water is called as demineralized. Why I am using demineralized water?
To avoid rust formation.
Very nice. Because if the minerals are added, because this that minerals will be present in the steam, and it is going to hit the turbine blades. So if the turbine blades are corroded, then it is very difficult to remove it and replace. So I am using demineralized water. And why I am using that demineralized water again? Because it is costly. So why should I use again demineralized water? So the steam coming out from the turbine, it is cooled down by using a condenser, and it is fed back to the boiler again. So this is a cycle, and this cycle is called as what is the cycle? It's called as Rankin cycle. Have you heard about this? In one of, I think, Vizag Steel, they have asked thermal power plant is working based on which principle or which cycle. It's called as Rankin cycle. Okay. Have you understood the working principle of thermal power plant? It's very easy. These figures, you just note it down. It's not a big issue and all. We should know what is actually happening in thermal power plant. You know that. The coal material Do we need a note? Demineralized water. Why demineralized water? These notes are enough, right? You are not preparing for university exam. An university exam, demineralized water. Why demineralized water? Because minerals will corrode the turbine blades. That's why we are using demineralized water. And the steam is condensed and fed back to the boiler again. What are the materials we are using? Coal. It's called as peat, lignite, bituminous, semi-bituminous, anthracite. If you go and see Ennur or some place called Attipattu Pudunagar, the coal is coming from Australia. See, even though we have large coal field in India, the ash content is very less. Ash content. Ash content in Indian coal is high. That's why they are using Australian coal. Ash content in Indian coal, this is about 20 to 40%. What do you mean by ash? Ash means when you burn the coal, the byproduct is ash, right? Can you hear me?
Yes,
Yes,
sir.
sir.
Okay. So ash means the byproduct of coal, because you know what is ash. So I need how they are handling this ash. When the ash is formed, this ash is mixed with the water. Now it's like a fluid. Ash is mixed with the water, and they are using centrifugal pumps. Centrifugal pumps to pump this ash to special ash ponds. Special ash pond. What do you mean by pond? In Malayalam, it's called as kulam. Tamil?
Same
Kulam.
kulam.
Kulam. Okay.
Yes, sir.
So this special ash pond, they are pumping this ash to this special ash pond. If they are not mixing it water, it is going to the environment. It is a big environmental effect. It will create adverse effects for the environment. So that's why they are mixing it water and they are sending it to ash pond. To produce 1 megawatt of electrical energy, they are using 10 to 15 tons per day. Which means for 1 megawatt of power production, they require 10 to 15 ton. 1 ton means 1000 kilogram. So you see how much is the coal requirement to produce 1 megawatt. So you have seen the coal is transported from the seashore by using trains. Have you seen coal transportation?
Yes, sir.
Yes.
Which means it requires huge amount of coal to produce this much of power. So that's why they are using special transportation techniques. So where these power plants are situated? Because if it is nearer to the coal mines,
Harbors.
what is coal mines, harbors? If it is situated nearer to that, the cost of transportation can be reduced, right? Cost of transportation can be reduced. So that's why the name remote power plants. That's why they are situated remote areas, remote power plants. So these points should be noted. That's all. right? Now, if you talk about the turbine, there are three types of turbine. Mainly, the turbine is classified into two. One is called as impulse turbine. Can you give some example? Impulse turbine. And second one is called as reaction turbine. Impulse turbine example is Pelton wheel. Very good. Pelton wheel. Reaction turbine, Francis or
And Kaplan.
Kaplan. Francis and Kaplan. So in thermal power plants, we are using impulse reaction turbine. Impulse reaction turbine. What do you mean by impulse reaction turbine? We'll see it. Impulse reaction turbine means, first of all, the steam is coming. So high pressure steam is used by this high pressure turbine, HPT. This is high pressure turbine. And the steam coming out from it, still it is having some pressure. So this steam, this is high pressure. This is medium pressure. Medium pressure steam is used by intermediate pressure turbine. So we have to make use of this steam. So this medium pressure steam is used by intermediate pressure turbine. So here you are using Pelton wheel, and here you are using Francis. Then we are using again the steam coming out from it. It is having still a pressure. It is having still some low pressure. Low pressure steam. It is again used by low pressure turbine, LPT. And the steam coming out from it is condensed. And it is feeding back to the boiler. This is called as Rankin cycle. So if they are asking what is the turbine used in thermal power plant, this is simply impulse reaction turbine. First of all, high pressure steam used by high pressure turbine, and the steam coming out from the turbine, still it is having some pressure, medium pressure. It is used by intermediate pressure turbine, and the steam coming out from it, still it is having some power. It is used by low pressure turbine. It's like Kaplan. So that's why the name, these are called as reaction turbines. This is called as impulse turbine. So nowadays they are using super thermal power plants. Now they are not using this kind of mechanism. But in the exam, you have some option like this, impulse reaction turbine. This is the correct answer. And the next point is very important. So in this session, we will discuss up to this thermal power plant. In the next session, we will be discussing nuclear, hydel, and all. Then we will be going for transmission. In thermal power plants, which generators are used? Asynchronous or synchronous?
Synchronous.
Synchronous generators are employed. Synchronous generators are employed. Right. And synchronous generators are again classified into machines over. Machines
No,
over for you?
Pending. Pending, sir.
Pending. Okay. Saline pole and non-saline pole, it is also called as cylindrical. Which is of highest speed? Which possesses highest speed?
Cylindrical.
Yes. What is the once they have asked a question, what is the maximum speed possessed by cylindrical pole alternator?
3,000.
Very good. Because Ns equal to 120 F by P. Frequency in India is 50 hertz. The minimum, the speed is to be maximum, which means the pole should be minimum. Number of poles should be minimum. How much is the number of poles? Minimum number of poles?
2.
2. Which means speed is 3000 RPM. And these alternators, the cylindrical power alternators are called as high speed alternators, or sometimes called as,
Turbo also.
yes, this question is asked once, also called as turbo alternators. Turbo alternators. Very, very important. Now, what is the efficiency of thermal power plants? Efficiency of thermal power plants is about
90%.
Overall efficiency is the product of your boiler efficiency. See, first of all, boiler is coming, then turbine is coming, then your generator is coming, right? So boiler efficiency into your turbine, or so you can say it as boiler means turbine and generator, you can take it as electrical efficiency. So boiler, you have thermal efficiency, then you have, it's also called as electrical efficiency. So overall efficiency is the multiplication of boiler efficiency, thermal efficiency, and your electrical efficiency. Now, this overall efficiency is equal to heat equivalent. This is not that much important. No need to mug up. Heat equivalent of electrical energy. Electrical energy. What is the unit of electrical energy? Kilowatt hour. Kilowatt hour divided by heat of combustion of coal. Heat of combustion of coal. That is kilocalorie. What is the relationship between 1 kilowatt hour and kilocalorie? 1 kilowatt hour equal to 860 kilocalorie. So overall efficiency is about not 90%, it's 30%. In modern thermal power plant, it will be going up to 40%, because so much power or energy is wasted. Note it down. You know that the overall efficiency is boiler efficiency, thermal efficiency, electrical efficiency. Boiler efficiency is high, electrical efficiency is high, but thermal efficiency is very low. That's why you are getting 30% to 40%. These numbers are important, okay. Life of thermal power plants. Can anyone tell what is the life of thermal power plants?
50 years.
No, 20 to 30 years. Next is one thing you should know down. Best example is, you see, in your you have seen trains. If you have seen a diesel loco, always producing a sound, right? It's not off. What is the main reason is that to start that engine, you require some 60 liters of diesel to start that engine. So this is a big loss. That's why it's normally if the train is coming to Chennai, and if the train is going after 5 hours, it will not be, that engine will not be off. For 5 hours, it will be called as hot reserve condition. Hot reserve condition means it will not be off. It will be simply, see what do you mean by hot reserve condition? You are riding a bike. After you are going to meet a signal, are you switching off your bike? See, you are riding your bike, and if you see a signal, are you going to directly turn off your bike? டைரக்டா இங்க வந்து சிக்னல் வந்து நிக்குது, இங்க பைக் ஆஃப் பண்ணீங்களா or is it in hot reserve condition?
நியூட்ரல்ல தான் சார் இருக்கும், ஆஃப் பண்ண மாட்டேன்.
ஆஃப் பண்ண மாட்டேன் பிகாஸ் அடுத்த சிக்னல் கிரீன் ஆகுதுக்கு அப்புறம் எடுத்துட்டு போகணும், அதுக்காக தானே.
ஸ்டார்டிங்
It's not like that.
ஃபியூல் ஆகும்.
அதிகமா ஃபியூல் ஆகும். It's called as for new bikes, if the signal is about 52 seconds, if you have 60 seconds left, then you can off your bike, because there is a calculation, fuel can be saved. But if it is less than 30 seconds, you should not be turning off your bike, because to start the bike again you require more fuel. So the same thing you can apply to train. Train means, see, it is a huge train, about 3000 HP horsepower. For your bike it is 16 HP for bullet. See the difference. So in order to start it again, it requires some 60 liters, a diesel generator and all. So it is maintained in hot reserve condition. The same thing is applicable in thermal power plants. You have a boiler, so you are using coal. So there is a process. First the coal has to be burnt and it has to boil the water and the steam is produced. It is a big process. So it is not shutting down. The thermal power plants, for maintenance purpose only, it is shutting down unless it is preserved in hot reserve condition. Hot reserve condition. If it is switching or shutting down, again the coal has to be burned and then it has to generate the steam. It is a big process. So it will say it takes several minutes. So we are not going for that. We will be maintaining in hot reserve condition. So the hot reserve condition means if you are seeing a signal, you are not turning off your bike because you don't want to waste your time. The same thing is applicable here. This is called as hot reserve condition. In the next session, we'll be discussing about nuclear power plant. So normally I would be taking only 1.5 hours per session because you would be bored. I will also be bored because it's an online program, right? So maximum 1.5 hours I will take. Otherwise you will get bored. Power system is an ocean. You just keep it in mind. So we'll be continuing our nuclear power plant, and soon I will be jumping into our transmission session, and we'll be going like that. I want to finish as soon as possible. Okay, so next session would be around 2 o'clock to 3 o'clock. I will inform Srinivas and he will inform to you. Suppose if somebody is giving your number, I will send this PPT to one of your number, or I will send to Srinivasa sir, he will send to you. Okay. So we'll wind up the session.
Okay, sir. Thank you.
Okay.
Thank you, sir.